Simulation is a very popular approach in business decision making. You may have heard of different kinds of simulations. There are simulations that are used for training, like flight simulator for training pilots. Business simulation games you might have played in your classes. For example, when I taught Business 101, the contemporary business practice, we did a simulation called Biz Cafe, where teams of students pretended they were running a coffee shop. We are going to focus on a type of simulation called Monte Carlo simulation that we use to make decisions in situations where there is a lot of uncertainty. Here is a definition. It's a simulation approach that uses a random sampling to represent uncertainty in a model representing a real system. So we build a model of real-life system so we could experiment on it. Typically, we don't have all the input parameters we need to build a model. For example, we're developing a new product. We want to build a model estimating the profit from it, but we don't know what the market demand will be. We're going to show an example where we use Monte Carlo simulation to perform a risk analysis. By risk analysis, we mean we want to quantify the likelihood and magnitude of an undesirable outcome. What we mean by that is, before we start something new, like going to a new product or a new project, we want to think of what is possible bad outcome that might occur, what is a bad thing that might occur, and what is a probability it will happen. In businesses, often the bad outcome is losing money. So how much money could I lose by launching this product? And what is the probability of losing this kind of money? You might say, well, wait, if there is some possibility of losing money, why bother? Then, well, don't do it, then do something else. Well, actually, for any venture we could go into, there is some possibility of losing money. Almost anything we do comes with some risk. So the next best thing to do is assess the risk so we could choose to do the things where the potential reward outweighs the risk. In this example, we'll do some risk analysis on a new product development. This company, Sanotronics, manufactures medical equipment. They've come up with a prototype for a new medical device. Now, when healthcares administer cancer drugs, there is a possibility they could inhale vapors from these drugs that could be pretty toxic. This device, looks something like this, will be a part of the drug administrating system that will minimize that exposure. In order to decide whether to manufacture and market this new device, Sanotronics would like to make sure there is a good chance that it will be profitable. Specifically, they would like to estimate the profit in the first year. Now, normally when you launch a new product, there is a good chance that you won't make money in the first year, but might start making profit as the sales increases. But Sanotronics has a pretty tight cash flow, so they want a good chance of making a positive profit even in the first year. So the question we want to answer is, what is a profit for the first year? But actually, we can't calculate that because there are a lot of unknowns. But we could answer questions like, well, what is the likelihood that we'll lose money? Well, let's see what data we're given. First, here are some things we know. The selling price will be $249 per unit, and the first year's fixed cost, administrative and advertising costs, will be $1 million. Now, the things we don't know. For instance, normally we don't know how many units we'll be able to sell, that is, like the first year demand. Also, we're told that the variable costs, like labor cost per unit and the parts cost per unit, are unknown. These unknown parameters are called random variables. Before I show you how to perform simulation on this, we're going to do some preliminary analysis. We're going to calculate the profit in 3 different scenarios. The base case scenario, that's the middle scenario, the worst possible case, and the best possible case. To do this, we are given 3 values for each unknown variable: the minimum value, the maximum value, and the most likely value. Now, let's think about how to calculate the profit. Well, how do you calculate the profit? You take the revenue and subtract the costs. Now, how do you get the revenue? You take the unit price multiplied by the units sold So it's 249 times X, where X is the demand. Now the costs, there are two kinds of costs, fixed costs and the variable costs. So we could sum them to calculate the total cost. The fixed cost is $1 million as given, and the variable cost, well, there's the two kinds of unit variable cost, direct labor cost and the parts cost. We're going to call them C1 and C2. So C1 plus C2 together is the variable cost per unit, and then we multiply that by the number of units. So the profit is 249x, that's the revenue, minus the cost, this other expression. So we write it this way, 249x minus, inside the brackets, all that expression. And then we can rewrite the profit function by combining the terms that contain x. So the 249x and then minus C1x minus C2x, or something like this. And then minus 1 million. So you could see that inside the parentheses, here is the unit contribution margin. Base case represents the most likely case, or the average case. So we want to plug in the most likely values for these random variables to calculate the profit. So we want to choose the most likely values, like 45, 90, and 15,000. That is these values, and plug them in here. So the profit is equal to 249 minus 45 minus 90 times 15,000, and then minus million. So that is, let's see, from the parentheses, 114. So that times 15,000 minus 1 million gives us 710,000. Now in the worst case, what numbers do we want to plug in? Well, for the costs will be the highest in the worst case. So that would be maximum, so 47 and 100. And then the demand will be the lowest in the worst case. So choose that. The profit is 249 minus 47 minus 100 times 0 minus 1 million. So that's, well, whatever this number is doesn't matter because it's multiplied by 0. So 0 minus 1 million, so it's $1 million. Now in the best case, the cost will be at their lowest possible level and the demand will be at the highest possible, so it's the remaining values, 43, 80, and 30,000. $43.80 times 30,000 minus 1 million. That is, the value from the parentheses is 126, so it's 126 times 30,000 minus 1 million. So that's 2,780,000. So what result do we have? Well, we could say this, that our profit is most likely to be somewhere around 710,000, but it could be anywhere between negative $1 million and $2.78 million. So this is a result of our analysis so far. Suppose you presented this result at a company meeting where they're trying to decide whether to launch this product. Is this enough information? Well, probably not. What you're saying is we could lose a lot of money, like $1 million, or make a lot of money. And it could be anywhere in between. What you could say is we will not lose more than $1 million. Now, would your manager say, well, this is a variable information. Now we could make our decision on whether to invest in this product. Wow, you are due for a promotion. Well, probably not. They might say, well, we understand it's difficult to make these kinds of forecasts, but we need a little more. Like, can you tell us what is the likelihood of losing as much as $1 million? What is the likelihood of making any positive profit on this? They would want to know not just the profits in the most extreme scenarios and the most likely profit, but they would want to know the probabilities associated with different profit levels. So that is what we could do with simulation. In simulation, we calculate profits for a lot of different scenarios, not just three. We generate specific values for the three variables and then calculate the profit. And then we generate another set of values for the three variables and then calculate the next profit and so forth. To generate the values for those three unknown variables, what we do is assume certain probability distribution for each variable. So each variable is treated as a random variable with a specific distribution associated with it. And in this example, we are given the distributions to use. First, we're given that the direct labor cost follows a discrete distribution like this. Discrete distribution means it's possible to make a list of the possible values. So we're given that the labor cost could be, it'll be between 43 and 47, and here are the possible values, 43, 44, 45, 46, 47, 5 possible values. And each possible value has a probability associated with it. So the word discrete here means separate, not continuous. So the possible values are just separate values. They are not an interval of decimal numbers. Second, we are given that the parts cost follows a uniform distribution between 80 and 100. So it will be the value should be somewhere between 80 and 100, and the probabilities are the same everywhere in that interval. The third variable, the first year demand, has a normal distribution with a mean of 15,000 and a standard deviation of 4,500. So you could see that each tick mark is for one standard deviation of 4,500. In simulation, you could think of the model as a box. So here is your model, okay, and you have the inputs going in and outputs going out. And the output here, for instance, will be like the profit we're calculating. And the inputs are the parameters like fixed costs, variable costs, and selling prices, and so forth. Now, some of the numbers are known, like selling price is $249, and the fixed cost, so that's the price, and the fixed cost is $1 million. But we have these three other variables that are not known, like the labor cost has discrete distribution, kind of like this, C1, and the parts cost has a uniform distribution, like this, and first year demand, X, has a normal distribution like this. So instead of inputting into the model like numbers, certain numbers like this, we're putting in for these variables, we're putting in the distributions, like distributions. So not a single value for each one, but distributions. So when we run the simulation, what we get for the profit is also some kind of distribution. Imagine something like this. So you get the profit distribution rather than one single profit value. But once you have the distribution of the profit, from this we could calculate all kinds of probabilities for different levels of profit. How we generate the profit distribution is we calculate profits for a lot of different scenarios by generating for each trial a number for each random variable. So pick one of these numbers and then pick a number from here. then pick a number from the somewhere over here, and then stick those in to the profit function and calculate the profit. And then you just keep repeating the process. For each trial, we pick 3 numbers from these 3 distributions and plug them into the profit formula to calculate the profit. So we'll have generated in that way lots and lots of profit values that we could build the distribution with.